Hello everyone and welcome to another episode on this very channel. Remember we are still on the same topic, probability, and in today's tutorials we shall be looking at the complementary rule of probability. If you haven't subscribed to the channel, kindly hit on the subscribe button for me. So what does the complementary rule says? Now it says that for any event, the probability of that event plus its complements sum up to 1. So let's take it that we are having the event A. Then the complementary rule says that the probability of A plus its complements should give us 1. And we can write it mathematically as the probability of A plus the probability of its complements should give us 1. Now the complement of A means the probability that A does not occur or the probability that A do not occur. So we can say that the probability that A occurs plus the probability that A does not occur must give us 1. So the complement of A means A doesn't occur. So let's take it that we are using the event B. Then the complementary rule says that the probability that event B occurs, plus the probability that event B does not occur should give us 1. In some books, you see the complements being written as, let's say, if it is event A, you are going to see something like this. A with a superscript of C. You can also see something like this. You can also see something like this. This means the same thing. And for us, we are going to make use of the bar. We are going to make use of what? The bar. So let's call this equation 1. Now from this equation, we can deduce two more equations in addition to this. So let's assume that we don't know the probability that event A does not occur, or we don't know the complement of A. We want to find it. So applying the little knowledge that we have in change of subject, we can say that the probability that event A does not occur is given as 1, and then we are going to transpose this to the right hand side to get probability that event A occurs. Let's call it equation 2. Now from the same equation 1, assuming that we don't know the probability that event A occurs, but we know the probability that event A does not occur. So we want to find probability that event A occurs. Applying the same knowledge that we have in change of subject, we can say that the probability that A occurs is 1. Then we transpose this to the right hand side to obtain probability that A does not occur. So these are the three equations that we are going to utilize under the complementary rule. One thing that you should take note is that complementary events are mutually exclusive. Now mutually exclusive means that these two events can't happen at the same time. It is either this happens and this does not happen, or this happens and then this does not happen. But the two events can't happen at the same time. So we say that complementary events are mutually exclusive. We can also use the Venn diagram to illustrate the complementary events. So we are going to draw our Venn diagram. So this is going to be our sample space. Let's use this circle to denote event A. So let's call this event A. And then all this region around the circle becomes the complement of A. So we have complement of A. This complement of A means that they are within the sample space, alright, but they are not part of event A. So now that we know this, let's look at how we can apply the complementary rule in solving questions on probability. So let's look at this particular example. The probability that Jones will pass the WASI exams is 2 out of 7. What is the probability that Jones will not pass the WASI exams? That is the first example. So let's use the letter J to denote Jones. So the probability that Jones will pass the WASI exams is 2 out of 7. And then the probability that Jones will not pass the WASI exams, we don't know. So let's use the letter X. We have just learned that the probability of an event occurring plus the probability of that event not occurring must give us 1. So therefore we can say that the probability that Jones will pass the WASI exams plus the probability that Jones will not pass the WASI exams should give us what? 1. Now probability that Jones will pass the WASI exams, we have 2 over 7. This we are using X, and that is going to give us what? 1. We are looking for this, so we can say that Rx is equal to 1 minus 2 all over 7, and that is going to give us S is equal to 5 all over 7. Therefore, the probability that Jones will not pass the WASI exams is 5 out of 7. Very, very easy and as easy as ABC. Let's look at another example. So we have the probability that it will rain today is 1 out of 5. We want to find the probability that it will not rain today. The probability that it will not rain today. So within the question, we know the probability that it will rain today, and that is giving us 1 out of 5. But we don't know the probability that it will not rain today. So let's use the variable x. We have just learned that the probability of an event occurring plus the probability of that event not occurring must give us what? 1. The probability that it will rain today is 1 over 5 plus probability that it will not rain today, we don't know, is equal to 1. We are looking for this, so you can say the probability that it will not rain today is 1 minus 1 over 5, and that is going to give us 4 all over 5. Very, very easy. The probability that it will not rain today is 4 all over 5. Let's look at this example. The probability of rolling a 1 on a die is 1 out of 6. The probability of rolling a 1 on a die is 1 out of 6. We want to find the probability of not rolling a 1 on a die. So we know that the probability of rolling a 1 on a die, so we are using R1 to represent the roll of a 1 on a die, is giving us 1 all over 6. But we don't know the probability of not rolling a 1 on the die. So let's use the variable x. And we have established that, or we have just learned that the probability of an event occurring plus the probability of that event not occurring must give us what? 1. We are looking for probability of not rolling a 1 on the die. So you can say that probability of not rolling a 1 on the die is giving us 1 minus, then we transpose the whole of this to the other side. So we have the probability of not rolling a 1 on the die. We have 1 minus, we had this to be what? 1 all over 6. And when you do the subtraction, you are going to get what? 5 all over 6. Very, very easy and then simple. So let's look at this example. An airline flight on a time 94% of the time. What is the probability that the airline will be late? So if you are not late, then you are on time or you are punctual. So if you are not punctual, then you are late. So we have late and punctual, on time and not on time. So we have our solution. So let's use OT for the airline arriving on time, and that is what 94%. So if you want to find the probability that the airline will arrive on time, it's going to be 94 over 100, and that is going to give us 0.94. Then we are going to use OT with the bar to denote the probability that the airline will be late. We have just learned that the probability of an event plus the probability of its complement should give us 1. So on time we have 0.94 plus not on time we have x is equal to 1. So when you do your algebra, you are going to have this. Brings us to the end of today's lesson. See you tomorrow. Bye bye.